Assalamu alaikum everyone. Let's start the very last lecture for this session. This is lecture number 30 for CS116 Object Oriented Programming. In last class, we explored the concept of software testing. In fact, whatever we studied in last lecture, that was just an overview of this field. This is a vast area and, a very important area when it comes to software engineering. So we explored some types of software testing and some approaches used in for software testing. And then we discussed how we can assert certain conditions in our code using that assert keyword. Now, in today's session, I'll discuss the solid principles of object-oriented design. These solid principles, they are one of the most influential set of object-oriented guidelines used today. And the most interesting thing about these principles is that these principles, they'll help you recall the fundamental object-oriented concepts like encapsulation, inheritance, polymorphism, and composition. So it's like, summing up everything in this last lecture. Now, this word solid is basically an acronym of 5 terms, in fact, 5 principles. Single responsibility principle, O stands for open close principle, then Liskov substitution principle, interface segregation principle, and the last one is dependency inversion principle. So let's see each one of these in a little detail along with related examples. Now, as I told you, that solid is a set of 5 principles, and by observing these rules in your code, you can make your code highly cohesive, maintainable, understandable, and extendable. By cohesive, here I mean that different elements in a module, they should belong together, like they should work towards a common goal. And then your code should be such that the programmer can easily debug it, can easily understand it, and if somebody wants to extend your code, that can also be done easily. So we'll see through examples like how these principles, they help you design such a code. These principles, they were developed by Robert C. Martin in the year 2000. He is commonly known as Uncle Bob in many pieces of literature. And then this actual term solid was coined by Michael Feathers. That means that Robert was the person who devised these 5 principles, and then Michael Feathers put those principles in this easy to remember acronym solid. Now, the main idea behind these principles was, according to Martin, was that there should not be any dependencies between different items in a module. Like classes should not be dependent on one another, or interfaces should not be dependent on one another. So the main focus of these principles is to remove those dependencies from your code, because according to Martin, if such dependencies, they exist in your code, they make your code rigid, fragile, and non-reusable. Now let's see these 3 terms: rigid, fragile, and non-reusable. Now, rigidity means that there are dependencies in your program such that if you make changes to one part of a program, that damages some other part of your program. Like if you are trying to fix a bug, that introduces a lot of new bugs in your code. Then comes fragility. Fragility means that you are not able to maintain your code. Like you don't know, there are so many places from where your code is broken, and you're not able to locate those errors or easily, or you're not able to fix them. And then immobility. Immobility is non-reusability of code. Like you are not able to use your code or any particular class from another class. That's the main spirit of object-oriented design, that it makes your code reusable. And if you're not able to do that, that means that all your effort is just limited to one application. It cannot be reused. So these principles, they aim to reduce those dependencies, hence overcome all these errors and make your code reusable. Okay, as discussed before, these are those 5 principles, and you see here we'll use further acronyms for each acronym, like S stands for SRP, single responsibility principle, then O for OCP, L for LSP, then I for IPS, and then D for DIP. Now, as the name suggests, single responsibility principle states that a class should have a single responsibility. Like, it should focus only on one problem, and there should be a single reason for it to change. Now, in this context, let's talk about a scenario. Let's suppose you start with a very simple class, a class having just one responsibility, or it performs only one specific function. But after some time, what you do, you keep on adding methods to it, because there are some methods which do not fit anywhere else. So you just keep on adding those methods to your class, and your class, it slowly becomes complex. And what's happening there, the class is coupling those responsibilities together, and then ultimately change to any one of those responsibilities may lead to the class being unable to meet its other responsibilities. And hence you can say that this coupling thing, or adding additional functionality to the same class, it leads to complexity of your class, and it makes your class more fragile. So this is what I was trying to say, that if a class has more than one responsibility, it becomes coupled. A change to one responsibility results to modification of other responsibilities, and most of the times that's unwanted or unintended. And it's just like a domino effect. You just touch one card and it affects all other cards in the line. And if you follow this principle, like if you strictly follow this principle and you keep one class for one function only, that makes your code more cohesive. And as I defined earlier, cohesive means that all units of that class, of a class, or all parts of a class, they work towards a single goal. That means a single responsibility or a single function. The concept of mixed-in class falls in this category, and we have seen that it's how easy it is to use a mixed-in class along with another class, and mixed-in class usually carries just one responsibility. Let's see an example of this. Here I'm about to define a class which will find area of a circle, and it will display that area to console, and it will also be able to save it in a file. So here is my class, a very simple code. This is the initiator where I am setting the radius. Radius is an instance attribute here. And then this is a simple function for finding area of the circle, right? Now, in order to display it on a screen, I am defining another method, display area method, and it will simply print it on a screen. And it is calling that instance method find area, and the result will be printed on a screen actually. Another method is there, save to file. It will simply find this area value to a file. So I'm opening a file in write mode, and then I am converting this value returned by area to string, and then I'm writing it to the file, and then I'm closing the file. Now this looks fine, there is nothing wrong with it, but where I am violating single responsibility principle, or SRP, I am defining two functions here. This class circle has two responsibilities, find area of the circle and display or output it. So in some literatures, they say that if you use this term and while defining responsibilities of a class, that means that you are putting more than one functionality in that class. So this means that I can break it into two different classes, one just for finding area and the other one for displaying that area or saving that area into area value into some file, right? So let's fix this. Now, using this principle, single responsibility principle, what I can do, I can modify that class and I can divide it into two smaller classes. So the purpose of my first class is just to find area. So here's the code. It's the same as before. And for the remaining part, I moved it into another independent class. and let's suppose the name of my class is display circle, and here I am defining my remaining method. So I'm uh, assigning a value to area through the constructor, and then I'm displaying that area using this method, and then I'm saving this value to a file using this second method. So here I have divided the functionality into two classes. Now this is sometimes difficult to follow these principles, but once you get used to this, this will surely make your code more usable than ever before. Okay, now this second principle, the open close principle, this is relatively easier to understand. In fact, first one was also easy, but this one is easy too. So here, this states that a software entity, a class or a module or a function, it is open for extension but closed for modification. That means that if you have already defined a class which has been tested and is bug free, and then if you want to add some functionality, then just don't alter that existing class. In order to add that functionality, what you do, you extend from that existing class. And we have seen this before also while we were developing, in fact, expanding that quiz game. There we wanted to add a new feature. For that, we extended those class which we had already developed. We did not change those class because there we discussed that these class might be used by some other parts of the same application. Okay, concept of abstract classes support this idea of open close principle, and I'll show this to you shortly in an upcoming example. Now let's try to understand this principle through an example. In this example, I have an existing class called shape, and there are two methods in this class. One is the initiator or the constructor, and what I'm doing here, I'm just setting radius as instance variable here, and the default value is 0, as you can see. And the other method is to find area, right? And it simply returns area of a circle actually. Now you see we can have so many shapes, different types of shapes, and the formula for calculation of this area is different for different shapes. So here I just put the formula for circle, right? Okay, now let's suppose I want to add functionality to find area of rectangle as well. So this find area function method will not work. So now let's see what choices do I have. The first thing that I can do, actually the problem is that the rectangle shape, it requires different set of parameters when it comes to calculation of area. So it requires two parameters, length and width, whereas circle required only one parameter, that was radius. So that means that I have to change this method find area. So the first choice is that I change this method find area, or I add another method find area of rectangle. But in any case, the problem with those parameters still remains. So I might want to change my initiator also. So this means these are a lot of changes to the existing class. And if I try to change the initiator or find area method, then it might affect the code which is using this shape class in this existing form. So fixing this, like adding this functionality of finding area to it, of a rectangle to it, it might break the existing code. And by that I mean that it might introduce some new errors, and the old code which was working before, it might stop working. So I'm violating OCP principle actually here. And how I am violating? Because I am trying to change the existing implementation. So OCP states that I should not change the existing implementation, rather I should extend it. So let's see what I can do. If I want to overcome this problem. One method of doing this is that we extend a class called rectangle from existing class shape, and we override that method find area. So here it is. It is overriding the initiator also, because rectangle has different dimensions as compared to circle. And then for finding area, we are overriding this method, right? And a better approach could be that instead of uh, defining a class shape that is specific for circle, and then for any other shape we are inheriting from that class, what we can do, we can make a general class shape abstract and then inherit any other shape like circle or rectangle or square from it. So that is going to be our approach number 2. So first of all, I am defining an abstract class shape. I hope you remember this. We have to inherit it from ABC, abstract base class. And all the methods in this class, they are abstract. So set dimensions is a method, then find area is a method, and let's suppose, okay, these two are the methods. Then I'm inheriting a class circle, and now I'm customizing the set dimension and find area method for specifically for circle. So here they are pretty much self-explanatory. And then I inherit another class rectangle from the same class shape, same abstract class shape, and there I am customizing these methods, set dimensions and find area for rectangle. So this is best among all the three approaches. And this shows that, the concept of abstract classes, it supports this open close principle. This is the third principle, the Liskov substitution principle, or simply LSP. And here's the formal statement, which is quite mathematical at a glance. And it states that let phi x be a property provable about the objects x of type T, then phi y should be true for objects y of type S, where S is also a subtype of T. Now, what we are trying to say here is phi is a method here, and x and y, they are objects. X belongs to class T and y belongs to class S, where S is a subtype of class. So simply it means that if there is a method which was called for an object of a class T, then same method should work for object of any subclass of T. Or in simpler terms, you can say that objects in a program, they should be replaceable with instances of their subtypes without breaking the code. That means if you are using an object and then in later at some point you replace that object with an object of a subclass of the same class, then your code should also work. This is an even simpler statement. If a parent class can do something, child class must also be able to do it. Now, this principle is named after the name of its proposer, and she was Barbara Liskov. She proposed this in a conference keynote in 1987, and later it was made part of these 5 object-oriented principle by Martin in 2000. Now, the main idea behind proposing this principle is that the client or the main program or the user of our class should not know about the change. For example, if you were using an object at some point and at some later point you try to replace it with a subclass, then the main interface should not be affected, or main program or the client should not be affected. That change should be transparent to them. This principle talks about the two very main principles of object-oriented programming. First one is polymorphism and the second one is inheritance. Actually, it enforces a programmer to implement inheritance in a proper manner. Basically, it's just an extension of OCP, open close principle, and it just makes sure that we extend the classes without changing behavior of the base class, right? I think this will be more understandable when we come to the example. The main point here that I can state to simplify these things is, I hope you remember in lecture 3 we discussed a definition for method overriding, and there we said that if a child class overrides a method of its parent class, then the signature of that method must remain exactly same. Like the name of the method should be same, the number of parameters and types that we are passing should also be same, and the return type should also be same. That is the actual definition for an overriding method. So this definition basically enforces Liskov substitution principle. So if you want to implement this principle, method signature, they must match and they should be exactly same in the child class and in the parent class. Return type should also be matched, and exception types must also match. So if we enforce these three rules, which actually belong to the actual definition of method overriding, then that means you are following Liskov substitution principle. Now, some of you might be thinking that this is something which is not valid in Python. Python does not follow this. You are absolutely right. Python allows us to define a different method signature when overriding a method of a parent class. You can do that, and Python has no objection on it. So that is fine. You can do that. But if you are doing that, that is correct in Python's way. But that means you are not following Liskov substitution principle. So that means that in Python, it is even harder to follow this principle or implement this principle in your code, because in other languages which implement that definition, that traditional definition of method overriding strictly, compiler or the interpreter might tell you that you are using the wrong signature. But in Python, it doesn't tell you about that. So if you want to implement this principle or enforce this principle, you will have to be extra careful. The second question is, what happens in case of multiple inheritance? So some literature suggests that in that case, the overriding method should be able to compensate for all the parents, or it should provide behavior which is sum of the behavior of all the parents. So this is another, a different scenario about Liskov substitution principle. Now let's see an example. In this example, I'll continue with the same old shape code. Here I'm defining that abstract class shape having these two methods. And then I'm deriving a class rectangle, which is implementing this interface or this abstract class shape. And here it is defining these two methods in its own way. Right now, let's suppose I want to add another class square. We all know that square is a kind of a rectangle, and it has some properties which are same as that of rectangle. They both are quadrilaterals. So what I can do, one thing that can come to my mind is that I should extend this class rectangle to work for square. There is not much difference. The only difference is that square requires just one parameter length, and all lengths are same, so it does not require two parameters. So one way of doing this is that I derive a class square from this class rectangle, and then I override this method set dimensions with this new method. Right now, you see here what I'm doing in set dimensions method. I'm changing the number of parameters. Now I'm passing only one parameter length, whereas in set dimensions of rectangle, I was passing two parameters, L and W. And then I have to change the implementation of find area method too. But for find area, the signature is same. The number of parameters and name of the method are same. Now, this is fine, but this is violating the Liskov substitution principle, because set dimensions method exists in both the classes, in the parent class rectangle and in the child class square, and the method definition is different in both. So if you were using somewhere an object of rectangle class and you try to change it to square class, then that will cause error, because square is taking just one argument, whereas rectangle was taking two arguments, right? So here, although this code will work, but this is violating Liskov substitution principle. Now, what we can do to solve or resolve this issue? Okay, one trivial thing could be that I use the same signature, like I pass two arguments to set dimensions method of square also, and what I do, I pass the same argument in both the parameters for L and W. Like it's it's kind of a fix that I'm passing the same value to both the parameters, and that will work for square as well. This is one way, and another way is to correct my hierarchy. And let's see how we can do that. So what I'm doing here, the main part, the abstract class shape remains same, and this rectangle class also remains same. Now for square class, what I'll do here, I will not inherit it from rectangle, but now I'll inherit it directly from the class shape. You see? And now this new implementation is not violating Liskov substitution principle. That means that an object of square class is not replaceable, is not a replacement for an object of rectangle class anymore. This implementation shows that, and this is now implementing Liskov substitution principle. Actually, it's not violating Liskov substitution principle now. The fourth principle is ISP, the interface segregation principle, and it states that many client-specific interfaces, they are better than one general-purpose interface. Basically, it deals with the disadvantage of implementing large interfaces. Now, before moving forward, let's clarify a concept about interfaces. In many languages, interfaces and abstract classes, they are two different things. But in in Python, we do not have any such thing as interfaces. We only have abstract classes. So the abstract methods that are provided in an abstract class, they are the interface in Python. Or you can say that if a class wants to implement an interface, what it will do, it will simply implement the abstract method of the associated abstract class. So basically, an abstract class provides or forms an interface, and any implementing class will provide concrete information implementation for those methods, and we can say that that class is implementing that particular interface, right? So what this principle actually means, that an interface should not enforce unwanted methods to a class or client. Now, as I said, that interface here in Python means the methods provided by an abstract class. So let's suppose you define an abstract class with 5 abstract methods. Now the implementing class should implement all those 5 methods. Otherwise, Python won't allow you to instantiate an object of that class. So let's suppose you do not want or to implement all those 5 interfaces, or 5 abstract methods. Only 3 of them, they are useful to you, but you cannot get away with just implementing those 3 methods. You have to implement all 5 methods, because uh, that's the rule. You have to implement all the abstract methods if you want to implement an interface, or if you want to derive from an abstract class. So this is what it means, that an interface, it should not force a client to implement all the methods. Let me give you an example. Let's suppose somebody comes to you and he's really hungry, and instead of giving him food, you ask him to do something else, like light candles and set the table and do this and do that. So that person only requires food, but you are offering him, or you are forcing him to do some extra things as well. So this should not be done. So the point here is that instead of making or putting all the interfaces in just one abstract class, you make smaller interfaces, so that a client can choose an interface of his or her own choice, and he or she will not have to implement all those extra methods. So implementing smaller interface will go in favor of the client, and it will also help reduce coupling in your code. Like all the clients classes or clients implementations, they won't depend on a single large interface. They'll have their own respective smaller interfaces. uh, I'll show you shortly that multiple inheritance and mix-in classes, they can be used to implement this idea. So let's move to the example. Now here I'm just discussing the example without formal code, but you can find the respective formal code in the file that I'm providing you along with this lecture. So I'm going back to my that abstract class shape. If you let's suppose we have these three methods: set dimensions, find area. These were the methods that we defined previously, and now I am adding one more abstract method here: find perimeter. Right? It will calculate perimeter for the shape and it will return the value to the caller. Now, let's suppose I derive a class rectangle, and basically this rectangle is implementing this interface. And this interface, it consists of three methods: set dimensions, find area, and find perimeter. So this is fine with rectangle. Rectangle has some dimensions, and then we can find area for a rectangle, and then we can calculate perimeter for a rectangle as well. So all three methods or the whole interface fits for this scenario when we are talking about rectangle. Now let's suppose I want to derive another class from this abstract class, and that is called circle. So now you see, set dimensions is fine. We can set radius using this method. Find area is fine. I can find area for the circle, but find perimeter, it does not fit much, because there is a parameter somewhat similar which is called circumference, but I don't like this name, find perimeter. I don't want to implement this for my class because the name doesn't suit my requirement. So let's suppose I want to implement only first two methods, set dimensions and find area, and then I want to define another method with another name, like let's suppose find circumference, but I cannot do that here, because if circle is extending this abstract class shape, then it must implement all three methods, and it's not allowing me. So that means it is forcing the circle class to implement find perimeter also, although that class doesn't like that particular method. So what should I do here? Okay, this is ISP violation. We are forcing that class circle to implement find perimeter method too. Now there could be multiple modifications. The one that I'm suggesting here is that I'll define smaller interfaces, many smaller interfaces in place of that one bigger interface shape. So now I have reduced this interface shape to just two methods, and then I'm defining another interface perimeterize having just one method, find perimeter, and a third abstract class or third interface circumferenced having just one method. Now you see, rectangle class can implement interfaces of its own choice, shape and parameterized, and same is the case with the class circle. So here I'm implementing smaller interfaces, and I'm not forcing any implementing class to implement any unwanted method. So okay, now one point that you should note here is that it implies to that first principle also, where we were talking about single responsibility in a class. Here previously what I was doing, shape was implementing or providing more than one functionality: area finding, and then parameter finding, and then setting dimensions. If I had followed that principle, single responsibility principle in the first place, then this problem should have never risen. So it means that if you are following these principles strategically and in an order, then you are saved from many complicated scenarios as well. This is the last principle, fifth principle, DIP, the dependency inversion principle. It states, actually it has two parts. The first part states that high level classes or modules, they should not directly depend on lower level classes or modules, but both should depend on abstractions. And the second part states that abstractions should not depend on details, but details should depend on abstraction. Now, this is a little tricky concept as compared to the other four that we have seen so far. First of all, let's clarify what is a high level module and what are low level modules. Higher level modules are the modules that work at the front end, and lower level modules are the modules that are working at the back end. Or in simpler case, higher level module or higher level classes, they actually use lower level classes. So lower level classes, they are subclasses working at the back end that help high level classes to function. And then high level classes are those which are accessed from the main program or by the user or by any interface. So what do we mean by this? That you see, we if higher level module or a higher level class or a front end class uses a back end class or a lower level class, then that means that those two classes, they are associated. This principle states that that association or coupling should be removed. So what this principle suggests, it suggests that there should be a middle layer in between, and these two classes, they should not interact directly, and they should interact with each other through that middle layer. That middle layer is called the abstraction layer. Okay, this is what I was telling you. So in order to avoid that dependency, we perform dependency injection. And dependency injection means inserting a layer of abstraction in between those two classes, those two interlinked classes. Now the main purpose of this is that the front end module, it should not know about the implementation details of the back end module. It should only know about the abstraction layer or the middle layer. Here by abstraction we means simply the middle layer. That middle layer, it could be an abstract class or it could be an ordinary class, but it is just serving as a middleman in between the front end and the back end. So the idea is that front end should not have the knowledge about the back end, and that means that we can change the backend at runtime, or the front end can choose any of the backends without changing many of its implementation details. Now let's see through this through a diagrammatic example first, and then we'll come to a coding example. Let's suppose I have a lower level module and it's called low level module 1, and then I have a high level module and there is some interaction between them. High level module is using low level module somehow. This relationship could be inheritance, or it could be simple composition or aggregation or any kind of association, right? Now let's suppose high level module decides to change this lower level module from module 1 to module 2. So there is another module 2, and now high level module wants to change to this. So this can be done, of course. What we need to do, we just need to change the implementation details of high level module, which is there to interact with lower level module. We just have to change the code. So we can do that. We simply remove and we add this new association. This is fine, but this is violating the dependency inversion principle, because here you see high level module is directly interacting with the lower level module. So the problem here could be that when switching from lower level module 1 to lower level module 2, it might be possible that we need to change a lot of code in this high level module, which becomes cumbersome and error prone at times. So what's the solution? The solution is enforcing this DIP in between. So now what I'll do here is this high level module, and here is my lower level module. I will not create direct connection between them. I'll create a middle layer. As I said earlier, this middle layer, it could be an abstract class or it could be an ordinary class. This is just a layer of abstraction, and this is the connection that we'll make. Right now, high level module is not directly interacting with lower level module. Instead, it is accessing this middle layer. Now what's the advantage? If I have another module, I just need to change, or I just need to connect it to the middle layer. High level module does not need to know about the internal implementation details of these two modules. So here how I have fixed it. Now let's see through a coding example to make things even clearer. Now here is an example. Now the scenario here is that, let's suppose we have a news and we want to print it using some medium. That medium could be newspaper, or it could be Facebook, or it could be television. So let's see how we can do that. Now this is my first class, which I'm considering a low level module, and it has a method print in paper. It takes input this news and time, like it's an evening paper or morning paper, and then it simply prints this statement printing in, let's suppose, evening newspaper, and then it prints the news. Okay, so again, it's a kind of a metaphoric example. Now let's suppose I develop a front end module or a high level module which uses this class. And here what I'm doing, I'm instantiating an object of newspaper type, and then I call this method print in paper on this object n. So this is the message, raining heavily today will be passed, and it will be printed in that particular format. So I hope there is nothing difficult. You can make out the output, or you can go and run that code file and see what output it produces. Now let's suppose I want to change it a little bit. I don't want to print that news in newspaper. Instead, I want to post it on Facebook. So what I'm doing here, I'm defining another class Facebook. It's another low level module. And here I'm just taking the news as input and I'm printing this message. In fact, I'm posting it on Facebook. Now you see there are a couple of differences between these two classes, Facebook and newspaper. The name of the method is different. There it was print in paper, and in Facebook it is post on Facebook. Then print in paper was taking 3 arguments, whereas this one is taking only 1 argument. Now if I want to adjust my front end, I'll have to make a lot of changes. First of all, I'll have to change the name of the class from newspaper to Facebook, where n is instantiated. And then I'll have to change the name of the method print in paper to post on Facebook, and then I'll have to omit that argument evening also. So that means there is a lot of work. So let's suppose I write new statements, and these statements are different from the previous ones. Now you see here, the point is, now this is violating this principle, front end directly accessing the low level classes. And what problem it is causing, that I have to make a lot of changes in front end if I'm changing the back end. So this is just one method. Just imagine if a front end is using a lot of methods from the backend modules, then you'll have to make a lot of changes to your code. So to avoid this, what we can do, we can inject a middle layer in between. In the modification, what I'm doing, I'll introduce a middleman, a class called publisher. And there is only one method in this class. This class method publish, it takes 3 arguments. News as before, time because it was used by one of those 2 classes. It was used by newspaper class. And the third argument, medium, is basically expected to be an object of any of those lower level types. Like it could be an object of Facebook class or newspaper class. Then what I'll do, I'll simply call publish it method on medium. This means that medium, it could be Facebook or it could be newspaper. That means now I need to introduce this publish it method into those 2 lower level classes. So first I'm talking about newspaper. Here I'm using this publish it method. It is passed those 2 arguments, n and t, that means news and time, and then it calls its own method in return, right? And that's how it will work. Now I'm not calling that print in paper method directly, but I'm calling a general method publish it. Same method should exist in Facebook class also. Here also I'm passing both the arguments, but you see t is not used inside the class. It's just there for syntax. Otherwise only n is passed to the next function. Sorry, next method, post on Facebook. Now you see, now we have made these 2 methods consistent, and they both have this method publish it method. And what then publish it method doing at the back end, that's none of our business. It could do anything. It could call post on Facebook method, or it could call 100 of other methods as well. So it's up to it. So from outside, we are accessing newspaper and Facebook class in the same manner using that publish it method. Now the front end, here what I need to change, now I'm defining or instantiating an object of publisher type, and I'm calling this method publish. And see the last argument, I'm passing that argument that is actually an object of newspaper type. So if I want to print my information in newspaper, I just need to pass that object of newspaper type, that's it. And if I want to print like post it on Facebook, I just have to pass an object of Facebook type. And apart from this, I do not need to change anything else. That means if you are changing your code, you just need to change that parameter medium and nothing else. The middle layer is taking care of the rest. Now you can even further improve this class. You can make that method publish in class publisher static, and that will eliminate this instantiation as well, then you can call that publish method directly using class name publisher. I'm not discussing that implementation here, but I have provided that implementation in the code file. You can go through it. It's pretty easy. One more thing that you can improve here is, let's suppose I call or I change this implementation, or I pass some object to this parameter medium which does not contain publish method. Let's suppose here in this last statement, you see I'm passing a list object. Now list class does not have that publish method. So what will happen? If you run this code, it will produce error. Now what you can do to avoid this, you can do a lot of things to avoid this. You can put some check in that publisher class, or you can even make your publisher class abstract and make this method publish an abstract method, so that any other class which wants to be a publisher must implement this publish method. Again, due to lack of time, I'm not discussing that implementation here, but you can find that implementation in the code file. There I have also defined a third class, television also, and that code is also pretty easy. You just go through it, and if you have any problem, we can discuss that in the live session. This is what we did today. We discussed these 5 principles known as solid principles, which make your object-oriented code really solid. And if you are following these rules while writing an object-oriented code, then your code becomes easily extendable, remarkably maintainable. That means that you can extend your code without touching the part that has already been debugged and tested. So it makes it easy to debug the newly added code, and again, it makes your application easily extendable and easy to understand. Now, these guidelines, they are not only for you guys who are beginners in this field, but they are for professional programmers as well. Many of the problems that nowadays even professional programmers face is due to the fact that they do not try to follow these principles. So you just try practicing these principles from the very start, so that when you get there in the field, they help you in writing easy, maintainable, flexible codes. Okay, now finally we have reached the end of this course. This is one of my favorite codes. It always seems impossible unless it's done. Remember how we used to feel when this semester was starting? It was everybody was scared. There was a lot of chaos, and now finally it's done. Actually, together we made it. Thank you all for coming this far with me, for being consistent, for being strong. As I told you in last semester as well, that you guys, in fact, we all are really, really blessed. You had the courage. We had the courage. We had the strength. We had the resources to overcome all the problems that were there during this period, during this pandemic. In fact, there are some students who went through really, really rough times, and but see, in the end, we all made it. And just take care of yourselves, take care of people around you. Inshallah, we'll meet soon in campus. Allah Hafiz.